Hello, in this short video of 10 minutes I'm very pleased to present to you Patrik, my colleague. He'll be presenting and discussing Contrail Security when integrated into Kubernetes. So this is Contrail as the CNI for Kubernetes, and we'll look at how we can enforce security policies across applications anywhere. And just to set the scene, if you remember in the other videos I was discussing how Contrail represents all network services in overlay flows. So as Contrail creates those flows dynamically, it has the opportunity to enforce security policies, but it can do this in a really cool and abstract way. So it can do it with tagging. So for example, you could build an application called MySQL. You could then set a security policy that says any application with a tag of database client who wants to connect to MySQL as an application is allowed to open this port. You can then reuse that MySQL policy no matter where the database is deployed and across many databases. So using this technique, you can build up complex policy enforcement across your SDN. And remember, the SDN can be deployed across public and private clouds. So you can enforce these security policies no matter where the applications sit. Now for Patrik's demo, he's going to be showing you two things. He's going to show you an application that gives you an inside view of security. It tells you which parts of the application can talk to which. He's then going to go into Contrail's GUI and show you how analytics forms an external view. So as a SecOps engineer, you can actually log into Contrail and you can ask it what this multi-tier application did, what type of traffic it generated, and what went where. Anyway, without further ado, over to Patrik.
Hello, this is a simple demonstration of a network policies in Kubernetes with a Contrail acting as a CNI. For visualization, we'll use an application based on Mesosphere project called Stars that was slightly modified, and that allows us to visualize communication between individual pods. So let's deploy that application. And this application will deploy namespace, services, deployment, and individual pod. We can monitor this using kubectl, get pod, services, deployment, ingress, and netpool in a given namespace in a combination with the watch command. We can see that one container is still being created, the rest of them are running, and at this point all of them are running, and we are provided with the ingress IP. Using our browser, looking at the ingress IP, we're provided with UI that displays that client path can reach backend and frontend, frontend path can reach client and backend can reach client and frontend. These are name of individual paths, as we can see here, and of course the services for each path. On the right side of the screen, this can provide us with the messages that will monitor the reachability from inside of the individual path. The first part of the command grabs the name, filters out the name, and then provide it as a second argument to kubectl logs -f tail in a given namespace, and we're just looking at any commands that have contain words reach. So we run that. We'll present it that on the top that client path can reach backend and frontend, and the second part, frontend can reach client and backend, and inside look of backend path. The first step in this demo is to prevent communication between individual paths. Let's apply step 1. What this does, it configures 3 policies that prevents front to talk to anybody, back and client to talk to anybody as an individual policy. If we refresh the screen, this is visible in the UI, and also we can see that the messages of reachability stops in each container. If we slightly modify the message and look at reachability, we'll be able to see that now we can see that client cannot reach neither backend nor frontend, and so on. And we can see that now we're filtering on a reach that we're matching also unreachable. So let's revert it and let's filter out only reachability. Let's start with the step 2, which provides that demonstration. In this step, client path will be able to reach front path using a policy. So if we initiate it, we can see that the client can now reach the front, and if you refresh the UI, that should be visible too. Client can now reach the front. Quick look at the policy, where we allow path with the role client on an ingress to reach front end on a port 80. The second part is to allow back to front, or rather I would say front to be able to reach back. It should be displayed in the second window, and we can see that the syslog just started. We can see that the back end is again reachable from front end. Refreshing the UI will provide that communication. And the policy, take a look at the policy, is again very simple. It is selecting for ingress front end, can reach the back end on a port 6379. And the last step is allow front end to talk to client, which again we'll see in a second window. And now we can see that we have a client that is reachable from front end and back end that is reachable from front end. And again, back end still cannot reach any of the path. Let's refresh the UI really quickly. And this is the application view. We can also quickly skip to the switch to the Contrail UI, and let's adjust the time so we can visualize our application. Let's look at communication in the last minute. You can see we have our deployment. I have added name to each deployment with the -dpl. So we have a client deployment, backend deployment, management, it's still replication, and front-end deployment. This is a communication, as we can see. Untag is the traffic coming out or paths talking through the namespace, for example, for DNS resolution and whatnot, and of course reachability to individual path. But let's focus on, let's say, communication from client to be able to reach front end. So let's take a client and let's see front end. This is our type of traffic. We can see that the policy that we're hitting is called client policy. And this is client to reach a front end is the second policy. The first one is front end to reach a client. But if we take a look at this, this is the policy that we're interested in, the first one. We can see that this policy allows port 80 to be able to reach from client to the front end. And if you take a look at our YAML file, we can see that we are allowing client to reach a front end on port 80, which is visually represented, and we can see how much traffic has so far been in that last minute been transmitted through this policy. We can of course modify the policy in a Contrail UI. We can see that the name of the policy is called front-end policy. In a Contrail, it will be prepended first by Kubernetes, then the name of the namespace. So in this case will be KS segdemo and front-end policy, which would be right here. You can see we have one rule, and in that rule we are permitting communication on port 80 from namespace segdemo and client to front end, which we were able to also visualize in security traffic groups. This was the visualization of the application. I believe this concludes our demonstration. Thank you and have a good day.